All right, let's continue our adventure into that 2014 released AP exam. I've got questions number 11 through 16. Remember, these are the no calculator questions. So on this first question, first of all, if you look at this, it says the graph of f prime. This is not the graph of f, it's the graph of the derivative. Always know what graph you're looking at. Okay, so this says from 0 to 6, we're looking at this thing, the derivative of piecewise. We see the pieces there, of course. Now it says that the original function starts at 1. At time 0, it's at 1. So what is the maximum value of f on the derivative? Now if you think about a number line, this is what I'm kind of picturing here, is at time 0, we're actually at 1 to begin with. This is at t equals 0. Now I look at this graph and I see this section of the derivative is positive. What does that mean? That means movement to the right. So for the first 3 seconds, this object is moving to the right. So this over here will be the maximum value then, because then it's going to move to the left and then back to the right again, and then a little bit more to the right. But the max value will happen at 3. I think that's pretty clear. And here's one of the tricks. One of the ways to do this is to find the area of that triangle. Find the area of that triangle, and that's going to be your net change. This will be the total change is the area under there. Well, the base here is 3. The height is 2. So 3 times 2 is 6, and then of course you have to divide it by 2 because it's a triangle. So we get a net change of 3. Now remember, we started at 1, so we moved all the way to 4. And 4 is the example. That's when it's at its highest value. And again, I knew that because the derivative is positive, which means the slopes are positive, which means it's going up or moving to the right, increasing on that number line. Okay, number 12. We have a function given by 9 to the x. If 4 subintervals of equal length are used, what is the value of the right Riemann sum? Okay, so we're going to divide this into 4 subintervals. So from 0 to 2, okay, that would be 2 subintervals. Now if I insert a 0.5 there and I insert a 1.5 there, now I've got 1, 2, 3, 4 subintervals, right? Now we're going to create rectangles and we're going to figure out the areas of all those rectangles. And the height of the rectangle will happen on the right-hand values, of this. So if you notice, each subinterval is 1/2 in width. These are all 0.5. So we're going to have 1/2 times. Now, we could do 1/2 times the height, 1/2 times the height, 1/2 times the height, or we could make it a little faster and we could use the distributive property to our advantage. So this is going to be f of 0.5 plus f of 1 plus f of 1.5. And if I were actually taking the exam, I probably wouldn't write this out. I'm just trying to help you understand what I'm doing. So I'm going to find these heights by putting 0.5 into the original function. Right? So this is going to be 9 to the 1/2 power. This is going to be 9 to the first power. 9 to the 3/2 power. You'll see why I'm writing it that way here in a moment. That's 1.5 plus 9 to the second power. All of that will be multiplied by 0.5 or divided by 1/2, or divided by 2, I mean. All right, this is the square root of 9, which is 3. 3 plus 9 plus, well, this is the no calculator section. How can I do 9 to the 3/2 power? 9 to the 3/2, if you remember, is really the square root of 9 to the 3rd power. What's down low is your root number, as I like to tell my students. So this is 3 to the 3rd, which is 27 plus 81. So if you add all these up, this is 12. 12 plus 27, that's 39, plus 81 is 120. But don't forget, we have to divide it by 2, and we get 60. So I'm sorry for the chicken scratch, just trying to move along. as you might do on the AP exam. So the right Riemann sum would be 60, and that's the answer. All right, moving on to 13. This is actually a pretty easy one because I'm sure you have that quotient rule drilled into your head, right? High and low, and the quotient rule goes like this. It's low d high, that's the derivative of the guy up top, and that's a 1, minus high d low, and the derivative of the bottom is 2x all over the denominator squared. And you see this is starting to look like some of the answers down below, but we got to do the algebra up here very carefully. We don't want to mess something up right here at the end and then end up missing it. That would be very sad. X squared plus 1 minus 2x squared plus 2x all over x squared plus 1. There's a fine line between being careful and also moving it along. We distribute this and we get negative x squared when you combine them. So I am kind of skipping a step here. Negative x squared minus 2x plus 1, if I put it in standard form, all over x squared plus 1, all squared. And I think that answer is there, isn't it? You see it? It looks like it's C. C, all right. We've got a few more problems lined up here. All right, the velocity of a particle moving along the x-axis, so it's moving left and right because this is a sinusoidal function, so it's going left and right. Its velocity is positive for a while, and then it's negative, and so on, at time t. If the particle at x equals 4 when t equals 0, so that means it's starting at 4. Don't forget that. It's starting at 4. What is the position of the particle? So s of s of 0 is 4. That's going to allow us, if you remember, that's going to allow us to solve for C. This is going to be one of those initial condition problems. So the position function is the antiderivative of the velocity function. So we have to do the antiderivative, and then we're going to solve for C. So if you do the antiderivative of this, it's a quick little u substitution, and you end up getting negative cosine of 2t. But don't forget, you're going to have that u equals 2t. So you're going to end up with a 1/2 out front when you divide both sides by 2. All right, try the u substitution, and you'll see what I mean on that. Plus c equals the position function. All right, now they gave us one of the data points. They said 4 is the output when you put 0 in here, and of course 2 times 0 is 0, plus c. What is cosine of 0? Again, no calculator section, so you're supposed to have that memorized. That's 1. So we then add 1/2 to both sides. We see that c is, I'm going to use decimals here, 4.5. C is 4.5. So I'm going to rewrite the function even though on the AP exam I would not do this. 2t plus 4.5. All right, so what does the question ask you to do at this point? Plug pi over 2 in there. So what happens is the 2 cancels with the 2, and you're left with cosine of pi, which is what? That is -1 times your -1/2 is actually +1/2 plus the 4.5 here is 5. 5, the answer is D, 5. It started at 1 and then it moved to the right all the way to 5 at that point in time. All right. Okay. I actually misspoke. It started at 4 and it moved to 5. There we go. All right. All right, 2 more problems on this video. This was a really interesting question. I like this one a lot. The function g of x is differentiable and increasing. So when I read this the first time, I thought, okay, that means g prime of anything is always positive for all real numbers. Okay, so it could be for anything. get to that in a second. On what intervals is the composite function, where you have this cubic on the inside, also increasing, or when is it going up? Okay. Well, I think we need to take the derivative of that guy. We need to take the derivative of the composite function and see what happens. Because that's when they're asking is, when is g prime of x third minus 6x squared always positive? That's what goes on in my head. I got to figure that out. So I'm going to take the derivative. What is the derivative of this when you have a composite function? Don't you always take the derivative of whatever you have? This is what we have. It doesn't matter that we don't know what g is. Okay, we take the derivative of it, but we have a chain. We have an inside function. So we multiply by the derivative of what's inside. That would be 3x squared minus 12x with a parenthesis around it. Right. This would be what g prime of x to the third minus 6x squared would be. All right, hopefully that's making sense here. All right, now this right here is always positive. Why? Because of what they told us earlier. They said no matter what you plug in g prime, you always get a positive number. Always, always, always. Now this part over here is a quadratic, and I'm going to just factor it. I'm going to factor 3x out, and I get x minus 4. So that means x equals 0 and x equals 4 are what we call zeros. And as you recall from algebra class, this is a parabola. The graph of 3x squared minus 12 would look like this. One thing in AP Calc is you always need to think graphically at the same time you're thinking numerically and algebraically and all this stuff. So look at this. This right here is when it's negative. This is when it's negative from 0 to 4. From 0 to 4 is when that's negative. So the question that it was asking is, when is the g prime of that mess, when is it positive? Well, that would be only when we have a positive times a positive. A moment ago I said this first thing is always positive, so we're good there. So when is this parabola positive? On this interval and this interval. That's why the answer is A. That answer is A. So this was a test of your understanding of the chain rule, and that we really didn't need to know what the g function is. We just needed to multiply by the derivative of that inside function at the end. All right, we got one more question here, and another good one. What is the limit involving an absolute value coming from the left? So that made this interesting. So you understand that x minus 3 with an absolute value looks like this. It's a shift to the right by 3. Right? So if we're coming from the left on this quotient function, we really only have to consider this side of that numerator function. Right? So this is really a piecewise function. To the left of 3 and to the right of 3. Those are the two pieces. And this question is only asking us about the left side. So I can literally replace it with this line. This is y equals negative x plus 3, because this hits at 3 and it has a slope of negative 1. You see that? It hits at 3 and has a slope of negative 1. So I can put that up here. Negative x plus 3 all over x minus 3. I then factor in negative 1 out of the top, and I get x minus 3. X minus 3 was already on the bottom. These cancel. Remember, you can always do algebra magic, algebra canceling and manipulation on limits. So now we have the limit as x goes to 3 coming from the left of a constant is just the constant. So that's the answer, letter B. All right, so we'll continue on with question number 17 in the next video. Good luck. Hope this is helping.